4, graphing f of x equals a, the quantity x minus h squared plus k, otherwise known as vertex form. All right, let's start with the warm-up. And again, remember, best way to do this is try them yourself. Pause the video, try them yourself, and then uncover and make sure that you're on the right track. And if not, then kind of figure out where you went astray. That's called learning at the ultimate way. Okay. So find the coordinates of the vertex. Some of these you can just look to figure it out. So go for that. Okay, obviously on this first one, this is the parent function. We know that that meets at the origin. Of course, you could plot points and kind of figure it out. You'd see that it looks like that. Okay, number 2, y equals x squared plus 2. Well, we know that this plus 2 just means that it is what? Vertically translated up 2 units. So it would be at 0, 2 would be the vertex. Okay, what about number 3? Well, number 3 is just what? It's what's a reflection in the x-axis from the parent function of y equals x squared, and it's also more bowl-shaped, or it's a vertical shrink. But is the vertex different? No. Okay, and then here on this one, we know that we have x squared minus 5x. We know we're going to need to use negative b over 2a to get the vertex. What's b in this case? Negative 5. What's a? 1. So we plug in, and we get 2.5. That tells us what the x coordinate is. We need to get the y. So what do? We plug in 2.5 for x into our x squared minus 5x. And 2.5 squared is the same as 25 squared, and then move the decimal over, so that's 6.25. And then minus 12.5 is negative 6.25. So what is our vertex? It is 2.5 comma negative 6.25. How can we check to make sure that's right? Well, hopefully you said, well, I could plug in negative 6.25 for y, 2.5 for x, and it would work. Okay, here we have y equals 3x squared plus x plus 2. How would you do this one? Well, same thing, right? We need to get negative b over 2a, which in this case turns out to be negative 1/6, right? B is 1, a is 3. And then once we have the x coordinate, which also, by the way, would be what? The axis of symmetry, x equals negative 1/6. We plug in negative 1/6 for x to figure out what the y coordinate would be. And hopefully you got 23 over 12. So our answer would be negative 1/6 comma 23 over 12. All right, so our learning target here is that you will be able to describe the graph of f of x equals a times the quantity x minus h squared and graph it too. And again, that is what we call vertex form. Okay? Does x squared minus 4x plus 4 equal the quantity x minus 2 quantity squared? How would we figure that out? Well, we could either factor the left side and see if it's this. And let's see. If we factored x squared minus 4x plus 4, that would be trinomial. There's no GCF to take out. Is it a perfect square trinomial? The first term's a perfect square. The last term's a perfect square. Is the square root of 4, which is 2 or negative 2, so let's use the negative 2, times the square root of x squared, x, that would be negative 2x doubled, what we have in the middle? Yes. Then it factors to x minus 2 squared. Or, even easier, we could have multiplied this out. Square the first term, x squared, double the product of the two terms. So the product of the two terms would be x times negative 2, which is negative 2x. Doubled means multiplied by 2, gets us negative 4x, and negative 2 squared is 4. So the answer is yes. So would those graphs be the same if I graphed x squared minus 4x plus 4 and I graphed x minus 2 squared? Well, of course they would be. Okay. So in 8.3, we learned how to graph from this form, right? We just did that. Figure out what the vertex is using negative b over 2a. That gives us the axis of symmetry as well. And then plot some points and reflect them across the axis of symmetry. Okay. Well, in this lesson, we're going to learn how to graph this form. okay, which again is what we call vertex form, okay? And yeah, I know you might be saying, well, we could just, multiply this out and then do it the way we just learned. True, but there's going to be a much faster, easier way or methods that we can do to graph this. Okay. All right. So you won't work with a partner, but you'll work with me. How great. Sketch the graphs of the functions in the same coordinate plane. Okay. How does the value of h affect the graph of y equals a times the quantity x minus h squared? So in other words, how does this h impact things? Okay, so we're going to graph f of x equals x squared. So go and graph that. Then graph g of x equals x minus 2 squared. Okay, so again, you're probably just plotting points. You're making, t-tables. And hopefully after you did that, you have something that looks like this. So here's our parent function, right? Vertex at 0, 0. And when I went and graphed g of x equals x minus 2 quantity squared, I notice that it basically looks like the same shape, but it's just what? It's just horizontally translated 2 units to the right. So I would describe that the value of h causes a horizontal translation. So the fact that h itself, forget about the minus sign, right? The minus is just part of the formula, right? The h is 2, meaning we're going to be translated 2 over. Okay? Simple as that. Okay, so let's see. What would you expect that f of x, which is equal to negative x squared, would look like compared to the g of x, which is negative and then x plus 2 squared? Think about how this form could be changed so that it's a minus here. Okay, so go ahead and sketch those graphs. And probably what you saw was it ended up being, yes, they're both down because we got a negative a, right? Negative in front. And then obviously the reflection of the parent function would have still in the origin is our vertex. And here we notice that we're 2 over. Well, isn't x plus 2 the same as x minus negative 2? So in this case, h is actually negative 2, which means we're translated 2 units to the left. Horizontally translated 2 units to the left. Okay, so now let's do this without graphing. Describe what you think the graph of y equals negative the quantity x minus 3 squared would look like as compared to our parent function of f of x equals x squared. So we're comparing, what do we think it would look like compared to this one? What would be different about it? Okay, well, obviously we have a negative sign here. So a is negative, right? So it would be a reflection in the x-axis. It's going to be facing down. And what about the minus 3 here? Well, doesn't that mean that h is 3, which means it would be what? Right, a horizontal translation 2 units to the right. Okay. All right, so here's the core concept that we're learning, or at least part of it. If we have a function that's in the form of f of x or g of x or whatever equals a times the quantity x minus h squared, when h is greater than 0, the graph is going to be a horizontal translation h units to the right of f of x equals ax squared. So f of x equals ax squared, you can see is in blue, so it's right here. And if it's x minus h, that means we're going to be moved over, because h is positive, whatever units to the right. Okay. Similarly, if h is less than 0, right? So instead of x minus, like let's say h was 3. Instead of x minus 3, if h was negative 3, it would be x minus a negative 3. So it could be x plus 3. We would be translated that number of units over to the left instead. Okay? The vertex of x minus h squared is always going to be h comma 0. Notice that we're still at the x-axis, right? So we know that our y-coordinate, our ordinate, is always still going to be 0, and we're just shifted over by whatever h is. So h comma 0 would be the vertex. What would the axis of symmetry be? Well, if we look here on the red one, it would just be whatever h's. So it would be x equals h. Okay. All right. So let's graph g of x equals 1/2 x minus 4 quantity squared and compare that to our parent function f of x equals x squared. So you can see the parent function is right here. Okay. And I kind of have the graph that we're going to be doing right here, but I want to show you how we arrived at that. So that's why I kind of have this up here with a couple things that are covered. Okay, so let's take a look at this. What can we tell just from looking at this? Well, A is positive, right? So I know it's going to open upward. And A is also between 0 and 1, which means it's going to be what? It's going to be a vertical shrink. It's going to be more bowl-shaped, okay? I know that x minus h, so h is equal to 4, means it's going to be horizontally translated 4 units to the right. Okay, so how would I go about graphing this? Well, I could graph the axis of symmetry because I know h is 4, so I could actually just put in my axis of symmetry, right? Okay. And I know the vertex, right? Because h is 4, and it's not translated up or down, we're going to do what? We're going to have 4, 0 as our vertex. So I can put that point in right there. Okay. Well, then you might say, well, how am I going to get other points? Well, we can just pick points. So let's plug in some numbers. Well, why not plug in 0 for x? That's easy, right? So if I plug in 0, 0 goes in right there. They're showing us that. So 0 minus 4 would be negative 4 squared. Negative 4 quantity squared is 16 times a half would be 8. So I would have 0, 8. Okay. And let's pick another number. Well, it's got a half in here and a 4. Let's keep with even numbers. Let's go with 2. So if I plug in 2, I have 2 minus 4, which would be negative 2. Quantity squared becomes 4 times a half is equal to 2. So I have another point I can plot at 2, 2. So that would be this point right here. Well, remember, we have this axis of symmetry. So we know that our parabola is going to be symmetric across this point, right? So if we have a point that is 2 units to the left of our vertex and 2 units up, we also know that we're going to have one that's 2 units to the right and 2 units up. So we could plot that point. So that would be what? That would be 6, 2. We also know that we're going to have a point if we have one that is, what, 4 to the left at this height of 6, then, I'm sorry, at 8, 0, 8. Then we also know that we're going to have one 4 this way. 4 plus 4 would be 8. So we'd have a point at 8, 8. We then could draw in our parabola. Okay? All right, so let's try one here. So we're going to graph g of x equals 2 times the quantity x plus 5 squared, and then we're going to compare that to f of x equals x squared. Okay. All right, well, I can already see that it's going to be a vertical stretch, right? A is greater than 1. And I know that we're going to have x plus 5 is the same as x minus negative 5. So we're going to have a horizontal translation to the left. So what would our axis of symmetry be? Well, wouldn't it be x equals negative 5? Because we know our vertex is going to be at negative 5, 0. So hopefully at this point, you've now put in your axis of symmetry first. Again, probably best to use a dotted line. Maybe use a colored pen or something for it if you wanted to, or a colored pencil. And then you put your vertex in. All right, well, let's pick some other points. Let's see, I picked negative 6. So if I plug in negative 6 plus 5 would be negative 1. Squared is just 1 times 2 would get us g of x, or y, is 2. Go plot that point. Okay. All right, let's see what else I picked. I picked negative 7. Okay. Notice I'm picking points that are on the left side of my axis of symmetry. Did I really have to do that? No, I could have picked points really on the right side, or one of each. Doesn't really make a difference. What we're going to end up doing is reflecting those points, so then we have a total of 5 points, because we have our vertex, that's 1, and then these 2, and then the 2 reflections of those across the axis of symmetry. Okay, so let's plug -7 in. -7 plus 5 would be -2. -2 squared is 4. 4 times 2 is 8. So we have those 2 points. Okay, so go ahead and plot those 2 points and then reflect those across the axis of symmetry. Let's see if you can get that right. So if you did that, you should have gotten -4, 2 and -3, 8. So your graph, then you draw your parabola in. Now that you have the 5 points to kind of give it some good shape, you should have had this here in bluish purple. Okay. Notice how it is steeper, like we said it would be, because a is 2, it's greater than 1. And also, we said it would be a translation 5 units over. Okay. So what would our comparison be? As we said, it'd be a vertical stretch by a factor of 2 and a horizontal translation 5 units to the left. Okay, good. Let's try another one. So we're comparing a parent function, and h of x is equal to -x minus 2 squared. Okay, so in this case, a is negative. That tells us something. What's h in this case? Remember, it's x minus h. So in this case, h is equal to, good, 2. So our axis of symmetry, vertical line, right, that goes through 2. That's x equals 2 because h is equal to 2. What's our vertex? Good, 2, 0. Awesome. So let's pick some other points to plot. Let's see, I chose 0. That's a pretty easy one. 0 minus 2 is -2. -2 squared is 4. Slap the negative on, and we get -4. Let's see what else I used. I used 1. 1 minus 2 is -1. -1 squared is 1, but then slap the negative on, and we get -1. So hopefully you plotted those 2 points, and then reflect those points across, and you would have gotten 4, -4, and 3, -1. So here's our parent function. Here's what we just graphed, right? Notice that if we put 0, -4 here, that would be what, right there, okay? Notice that that is 2 units to the left of our axis of symmetry, so we need to have another point 2 units to the right. And that's where we got the 4, -4, right? Same with if we had 1, -1, that's right here. That's 1 unit to the left of the axis of symmetry, so we know we could plot another point right there. Okay, so what would our comparison be? Our comparison would be that it's a reflection in the x-axis, and it's a horizontal translation 2 units to the right. In other words, starting from here, we would have flipped it over, and then we would have slid it over. Okay. All right, second part of the lesson. Now we're going to be graphing f of x equals a times the quantity x minus h squared, and this time we're adding a k in, okay? Now you may already have a sense of what that's going to do. Remember when we graphed something in the form of ax squared plus c? So we just had that constant on the end. We saw what happened, right? It ended up being a vertical translation, either upward or downward by a certain number of units, the number of units that c was. Well, basically, k is going to end up doing the same thing here, okay? So the vertex form of a quadratic function is f of x equals a times the quantity x minus h squared plus k, okay? Where a does not equal 0, right? If a was 0, then this whole thing just goes away. Okay. The graph of f of x, a times the quantity x minus h k plus k is a translation h units horizontally and k units vertically of ax squared. So in other words, we're going to move horizontally depending on what h is. If it's positive, we're going to move to the right. If it's negative, we'll move to the left. That's from this h right here. And we're going to move up or down, a vertical translation, depending on what this constant k is. Okay? The axis of symmetry, obviously, would be what? H comma k would be our vertex. Our axis of symmetry would be x equals whatever our x coordinate is. In this case, it's h. So take a second to kind of soak all of that in, okay? In other words, what we're doing now is we're just, instead of having like a +0, with, for example, like when we graph something like this, we could have put a +0 in the end. So k would have been 0, which would have meant we didn't move horizontally. We would move horizontally. We wouldn't move vertically for our vertex. Here, we're going to move both horizontally and vertically, depending on h and k. Okay, so we're going to graph g of x equals -2 times quantity x plus 2, quantity squared, plus 3. Compare that to our parent function. Okay, so what's h in this case? That's the first thing to recognize. Good, it's -2. And what's k? It's 3. So what's our axis of symmetry going to be if our vertex is going to be h comma k? Well, it would be whatever h is. And h in this case, we said, is -2. So x equals -2 because h is equal to -2. We know our vertex, as I just said, is -2 comma 3 because h equals -2 and k equals 3, right? So it's all coming from this formula. Way easier than having to like multiply this out and plot points and all that. Okay, so we have a vertex. You have your axis of symmetry that you've drawn in. Now we need to just kind of find two other points. Looks like I would, 0 is a great one to plug in, right? Easy to use. So if x is 0, 0 plus 2 is 2, 2 squared is 4, times -2 would be -8, plus 3 gets us -5. And what else do you think would be a good one to use? -1. -1 plus 2 is equal to 1. 1 squared is 1 times -2 is -2 plus 3 gets us 1. Awesome. And then you reflected those points, hopefully. Got -4, -5, and -3, 1. So your graph would have looked like this. Again, the orange one is our parent function. Okay, so what's the comparison here? Well, it's a reflection in the x-axis, right? So we would have turned it over. We would have stretched it because a is less than -1, so it's going to be a vertical stretch. It's thinner. And then what? We translate it 2 units to the left and 3 units up. So really 4 different things that we could say. Reflection x-axis, vertical stretch by a factor of 2, vertical translation 3 units up, and a horizontal translation left of 2 units. Okay? All right, so go ahead and try this one, and then we'll come on back together. Okay, so hopefully you saw that h in this case was 1, k was 6. So our axis of symmetry is x equals 1 because h equals 1. Our vertex would be h comma k, so 1 comma 6. Again, because h is 1 and k is 6. Find 2 other points. Let's see what I used. I probably used 0 since 0 wasn't part of our vertex. I did. I got 9. And I used 2.5, probably so it didn't go off the graph. And you may have used something different. It doesn't really make too much difference. But the way I did it, I would have reflected and got those 2 points. And my graph would have looked like this purple one here. Okay? Again, in terms of the reflecting points, so let's look at 0, 9. 0, 9 is right here, right? Again, we'd want to keep the same y coordinate, but just go to the other side of our axis of symmetry by however much this one is to the left. So if it's 1 unit to the left, I want to go 1 unit to the right. I'd put a point right there. Okay? So what would our comparison be? Well, I can see that it's a vertical stretch, obviously, because by a factor of 3. What else do we know? It's not a reflection in the x-axis because they're both opening up, but it's a vertical translation, 6 units up, and a horizontal translation, 1 unit to the right. Okay? All right. Hope you're doing a good job of pausing this when you need to really absorb it and try it yourself. All right. Now, let's consider g of x. That's negative 2 times the quantity x plus 2 squared plus 3. And then we're going to graph f of x, which is g of x plus 5. So notice that the function f of x here is in the form of g x minus h, where h is equal to negative 5. Okay, remember x minus 8. So x plus 5 would be the same as x minus negative 5. So the graph of f is a horizontal translation 5 units left of the graph of g. So what we would need to do is we would need to graph g and then just subtract 5 from the x-coordinates of the points on the graph. So for example, if I went over here, I know that h is negative 2, k is 3, right? So I'd have a vertex at negative 2, 3. And then I could, plot other points, draw this. But if my vertex is negative 2, 3, and I want to subtract 5 because it's a horizontal translation 5 units to the left, instead of being at negative 2, 3, I'd be at negative 7, 3. And then you would do the same thing with the other points. And eventually be able to have 5 points and kind of draw our curve. Okay. What about if we have g of x, same formula here, but it's g of x and then minus 3. Notice over here it was x plus 5 inside the parentheses. Here it's minus 3. What do you think that one's going to look like? Well, wouldn't it just be that f of x would be the graph g of x, and then this minus 3 would mean what? Wouldn't that just mean that it's going to be a translation, a vertical translation up 3 units? Or excuse me, down 3 units. Sorry, because it's minus 3. Notice that when I put the minus 3 on there, this becomes a 0. So we end up getting k is 0. So we have a vertex that's going to be right on our x-axis. So we would just say that it's a vertical translation down 3 units. Okay. Oh, this is a good problem. Love this. Reminds me of Las Vegas. Wish I was there now. Water fountains are usually designed to give a specific visual effect. For example, the water fountain shown consists of streams of water that are shaped like parabolas. You can see that in the picture, hopefully. Okay. Notice how the streams are designed to land on the underwater spotlights, right? So it makes it look real pretty, and you can kind of see the whole arc that way. Write and graph a quadratic function that models the path of a stream of water with a maximum height of 5 feet, represented by a vertex of 3, 5. That would make sense that would be a 5, right? Because it's a one that's opening down. So the highest point would be the vertex. Landing on a spotlight 6 feet from the water jet, represented by 6, 0. So for example, if this was kind of maybe the edge here was our y-axis and this is our x-axis, this would be 0, 0. And we're saying that this would come back and land at 6, 0. Okay, so we have to write it and graph it. Okay, so let's write it first. Well, what do we know? Okay, well, we know the vertex form is what? F of x equals a, and hopefully you're going to say x minus h quantity squared plus k. Good. Now, we know the vertex is 3, 5. That means h is 3, k is 5. So can't we substitute 3 for h and 5 for k? Yes. And we already have a point that's going to be on our parabola. Remember, every point that's on a parabola means it satisfies the equation for that parabola, right? So we know one point that's on ours, besides 3, 5, is 6, 0. So doesn't that mean we could plug in 6 for x and 0 for y or f of x? If we do that, doesn't that leave just one variable to solve for, which is a? So let's go ahead and simplify and solve for a. So 6 minus 3 is 3. 3 squared is 9. So I would have 0 is equal to 9a plus 5. And then to solve for a, what would I do? Subtract 5, divide by 9, and I get a equals negative 5/9. So what would our final equation be? It's going to be f of x equals negative 5/9 times the quantity x minus 3 quantity squared, and then plus 5. Okay, and now all we have to do is graph it. We already know we have an axis of symmetry, right, of x is going to equal h. H in this case is 3, so x equals 3. We know our vertex, we were told, is 3, 5, or we can get that from the formula here. We already have 6, 0. Well, we know that the starting point is 0, 0, where the water shoots up, so we can plot a point there, right? And let's pick another point. I used 4.5, and I got 3.75 for y. So again, we would reflect those points. We already said we'd have 0, 0, and 1.5, 3.75. And this is what we would have had. So we had this point, we had our vertex, we reflected this point. Since it's 3 units to the right of the axis of symmetry, we can put another point 3 units to the left. I decided to use 4.5, right? So that was this point right here. I got 3.75, so 4.5, 3.75. This is what? It's 1.5 units to the left of the axis, to the right, excuse me, of the axis of symmetry, which means we can put a point in 1.5 units to the left. Okay. Okay, so what if the vertex, instead of being 3, 5, is instead 3, 6? So in other words, it's shooting higher, right? Okay, so what would we do? Well, we know h and k would be 3 and 6, so we could plug those in. It didn't say that it was landing in a different place, so we're going to assume that it's still landing at 6, 0. So we could plug in 6 and 0 for x and for f of x. We did right there. 0 for f of x, 6 for x. Simplify to get what a is. And in this case, 6 minus 3 is 3. 3 squared is 9. We have 0 is equal to 9a plus 6. Subtract 6, divide by 9, and a equals negative 6/9, which reduces to negative 2/3. So we could write the equation as f of x equals negative 2/3 x minus 3 squared plus 6. Okay, so now let's graph it. We know it's going to look pretty much like the other one, except it's going to go higher, right? And what's our axis of symmetry? 3, right? Because h was 3. Our vertex, we already know, is 3, 6. We know it goes through 6, 0, so we could always plot that point in 0, 0. So 6, 0 and 0, 0. And then let's pick another point. I used 1 and ended up getting 10/3. So if I plotted 1, 10/3, 1 is what? It is 2 units to the left of our axis of symmetry, which means we'd want to plot a point 2 units to the right of our axis of symmetry. What's 2 units to the right of 3? 5, right? So it would be 5, 10/3. And you should have gotten something that looked like that. Okay, exit ticket. Okay, you're given that. Tell me what you know about the function, and then go ahead and sketch the graph. What do we know? Opens up. Good. Is it going to be steeper? What do we know about it than the graph of y equals x squared? It's wider, right? Why? Because a is between 0 and 1, right? What's the vertex? Notice what form it's in, vertex form. Negative 8, 4. Remember, x minus h. So x plus 8 is the same as x minus negative 8. So it's negative 8, 4. What would the domain be? It's a function, folks. All real numbers. Good. What's the range? Okay, well, if the vertex is negative 8, 4, and it opens which way? Oh, yeah, up. What's our range going to be? Y is greater than or equal to 4. And it's a vertical blank by a factor of blank. That's talking about how steep or bowl-shaped it is, right? It's a vertical what? Shrink by a factor of 0.5 or 1/2, right? And it would be a horizontal translation. In other words, think about where the vertex would be compared to our parent function of y equals x squared. It'd be a horizontal translation by whatever h is, right? So 8 units in which way? Hopefully you said left. And it's a vertical translation, whatever k is, right? K is 4, so it's 4 units up. And then if you went and finally graphed it, you would put the vertex in, you would pick a couple of other points, and you would have a graph that looked like this. Okay, hope you had a good understanding of that. You really did a good job of trying those on your own. And obviously we'll take questions. Remember, you can always use the Dynamic Student Edition to help you out as well. Looking forward to success with this. All right, see you later.